Every summer, AAA receives over 8 million roadside assistance calls. 8 million drivers stranded on the side of the road, waiting for a tow truck, watching their afternoon disappear. Of those 8 million calls, cooling system failures, engines that overheated, account for 11% of all breakdowns, according to industry breakdown data compiled from AAA records. That is nearly 900,000 drivers per summer, sitting on the shoulder of a highway with a hood full of steam, a temperature gauge pinned in the red, and a repair bill waiting for them at the end of a flatbed truck. I'm Tyler Williams. Most people know me as Motor Grease Monkey. 15 years in garages dealing with engines, some saved in minutes, others completely destroyed. And today we're talking about why an overheating engine can either be a quick $20 fix or turn into a $6,000 disaster. Because it usually starts small. A tiny leak, low coolant, something easy to ignore. And the number that every single one of those drivers needed to know, the number that separates a $20 outcome from a $6,000 outcome, is 4 minutes. The length of time between the moment that temperature gauge first touched the red zone and the moment the driver made the decision. That determined which bill they were going to receive. Because here is what the repair industry will not tell you up front, before they have already started writing the estimate. The majority of engine overheating events begin with a cause. That costs between $15 and $50 to fix. Low coolant, a failed radiator cap, a small coolant hose leak, a $15 bottle of coolant at any petrol station, added correctly and promptly, prevents the chain of destruction that leads to the $6,000 bill entirely. The $6,000 bill, the blown head gasket, the warped cylinder head, the engine replacement, does not happen because the engine overheated. It happens because the engine overheated and the driver kept driving. 4 minutes, 5 minutes, 10 minutes, down the highway with the temperature gauge buried in the red, hoping it would sort itself out, not knowing that every single second of operation at that temperature was compounding irreversible damage on one of the most expensive components in the vehicle. Today we are going to show you exactly what happens inside your engine when the temperature gauge moves into the red, exactly what the cost looks like at each stage of that process, the precise 4-minute protocol that separates a minor inconvenience from a catastrophic repair, and the 2-minute monthly check that prevents the majority of overheating events before they ever start. First, understand the machine you are trying to protect. Your engine operates within a specific temperature range, typically between 195 and 220 degrees Fahrenheit. For most modern passenger vehicles, inside that range, the metal components of your engine maintain their design tolerances. The pistons fit precisely within the cylinders. The cylinder head sits flat against the engine block. The head gasket seals the combustion chamber perfectly. The oil maintains its viscosity. Everything is calibrated to work at this temperature, and only this temperature. The cooling system's entire job is to keep the engine inside that range. Coolant, a 50-50 mixture of antifreeze and distilled water, circulates continuously through the engine block, absorbing heat from the combustion process, traveling to the radiator, releasing that heat into the outside air, and cycling back through. The water pump drives that circulation. The thermostat regulates it. The radiator dissipates it. When any single component in that chain fails, the coolant level drops too low. The water pump stops circulating. The thermostat sticks closed. A hose cracks and leaks. The heat that was being absorbed and carried away by the coolant starts accumulating instead. The temperature climbs. The gauge moves. And the clock starts. Now understand the cost ladder. Because it is not a binary choice between cheap and expensive. It is a staircase, and every minute you keep driving moves you one step higher. Stage 1 is the warning stage. The temperature gauge moves into the upper range, but has not yet entered the red zone. At this point the engine is hot, but has not yet exceeded its metallurgical tolerances. If you pull over now, turn off the engine, and allow it to cool for 30 minutes before investigating, there may be zero engine damage at all. The cause is almost always low coolant. A $15 bottle of premixed coolant from any petrol station, added to the coolant reservoir once the engine has fully cooled. Never when it is hot, because pressurized boiling coolant will burn you severely, addresses the immediate issue. Total cost of a Stage 1 response, $15 to $20. Stage 2 is the overheat stage. The gauge enters the red zone. Steam begins venting from under the hood. The engine control module detects the temperature exceedance and begins reducing engine power to minimize further damage. At this point the coolant is boiling and escaping the system. The surface temperature of the cylinder head is above 225 degrees Fahrenheit. If you pull over immediately at Stage 2, and call for a tow rather than attempting to drive further. You may escape with a head gasket replacement. A serious repair, but a recoverable one. Head gasket replacement on a 4-cylinder engine runs between $1,500 and $3,246 at current RepairPal average pricing, depending on the vehicle. That is a significant bill. It is not a catastrophic one. The engine is recoverable. Stage 3 is the destruction stage. The coolant is gone. The engine continues to operate. Cylinder head and piston temperatures climb past 400 degrees Fahrenheit. The aluminum pistons expand faster than the steel cylinder walls can accommodate. The aluminum piston material is literally smeared onto the walls of the cylinders. The cylinder head, which must be perfectly flat to seal against the engine block, warps under the extreme heat. The damage at stage 3 is not a head gasket replacement. It is an engine rebuild or an engine replacement, starting at $3,000 for a used engine swap, and reaching $6,000 to $10,000 or more for a complete rebuild or new engine installation. On many common passenger vehicles, if you continue driving your car with a blown gasket, it could lead to irreparable engine damage, and an engine replacement that could cost you in excess of $10,000. The staircase from stage 1 to stage 3 is not a matter of hours. It is a matter of minutes. The driver who sees the gauge in the red and pulls over within 60 seconds is at stage 1 or early stage 2. The driver who sees the gauge in the red thinks, "It will be okay, I'm almost home," and drives for another 4 to 8 minutes, has moved themselves to stage 3. The repair bill that results, the $6,000 engine replacement versus the $20 coolant top-up, was determined entirely by that decision, not by the mechanical failure, by the response to it. Here is the 4-minute protocol. Memorize it before you need it. The moment your temperature gauge moves into the red zone, or you see the engine temperature warning light illuminate, you have 4 minutes to execute this sequence before the probability of serious engine damage rises sharply. Step 1. Immediately turn off the air conditioning. The AC compressor puts additional load on the engine and increases heat generation. Turning it off reduces the thermal demand on the cooling system and buys you seconds of margin. Do this before anything else. Step 2. If you are on a highway or in traffic, turn the heater on full blast. This sounds counterintuitive. The cabin heater draws heat from the engine cooling system, pulling thermal energy out of the engine and venting it into the cabin. It will be uncomfortable. It is also the fastest way to reduce engine temperature while you are still moving. Experienced mechanics use this trick every time. Most drivers have never heard it. Step 3. Signal, move to the right and pull over as quickly as safety allows. The goal is to stop the engine. Every second the engine runs at red zone temperatures is compounding damage to the cylinder head and head gasket. You do not need a rest stop or a car park. Any safe shoulder, any side street, any place where you can stop and get safely away from traffic. Step 4. Turn off the engine. Do not open the hood yet. The coolant system is under extreme pressure, and the fluid may be above boiling temperature. An improperly opened radiator cap under pressure will send superheated coolant and steam directly at your face and hands. Wait a minimum of 30 minutes. Watch the temperature gauge drop from the hot toward the normal range. On most vehicles the gauge remains functional, with the ignition in the accessory position, so you can monitor it without running the engine. Step 5. After 30 minutes minimum, if steam has stopped venting and the gauge has returned to normal range, carefully open the bonnet. Locate the coolant reservoir, the translucent plastic tank attached to the radiator by a hose, typically labeled with MIN and MAX lines. Check the level. If it is below the MIN line, coolant has been lost somewhere. Do not add coolant if the engine is still hot. If you have pre-mixed coolant in the boot, and after watching this video you will add it slowly to the reservoir, replace the cap, and check whether the level holds. If the level is critically low and you have no coolant available, a 50-50 mixture of water and the correct antifreeze type from any petrol station is the emergency substitute. Step 6. If the level returns to normal and the gauge stays in the normal range, on a cautious restart, you can drive carefully with the heater on and the AC off, monitoring the gauge constantly, to the nearest repair shop. If the level drops again quickly, the coolant is still escaping somewhere, and the vehicle needs to be towed. Do not drive a vehicle that is losing coolant. The second overheating event will be worse than the first. Now here is the 2-minute monthly check. That prevents the majority of overheating events before they start. Cooling system failures are responsible for 11% of all roadside breakdowns, and the vast majority of those failures begin not with a catastrophic mechanical failure, but with a gradual loss of coolant that was never noticed. because the driver never checked. The coolant reservoir takes 2 minutes to check, requires no tools, no mechanical knowledge, and no getting under the vehicle. Once per month, with the engine cold, not after driving, not after the engine has been running. Open the bonnet, locate the translucent coolant reservoir, and verify the level is between the min and max marks. That is the entire procedure. If it is below min, add premixed coolant. If the level drops noticeably between checks, meaning coolant is disappearing somewhere, there is a leak that needs to be found and addressed before it becomes an overheating event. While you are there, look at the coolant itself. Healthy coolant is bright green, blue, orange, or yellow, depending on the type, and it should be translucent. Coolant that is brown, rusty, or has visible particles in it has degraded past its corrosion-inhibiting effectiveness and needs to be flushed and replaced. A service that costs $100 to $150 at any independent shop, and that prevents the internal radiator and cooling passage corrosion that causes the clogs and restrictions that lead to overheating in the first place. According to the AAA, regular maintenance can reduce the risk of a roadside breakdown by up to 50%. If this video changed how you think about that temperature gauge, subscribe and I will see you in the next one.